Hello. In this video, I'm going to be working on this truss, which can be found on page 5 of the Vector Active Structures Problems file on ELMS. Okay, and I'm going to be using the joint method for this truss. Okay, so the first thing to do, number one, is calculate the reaction forces. Okay, so I've got an RA and an RB, and you'll notice the truss is kind of cantilevering over. So I can't just divide by 2. I'm going to have to use the moment to find each reaction force. So first, let's see what the total load is. Total load equal to, got 2 kips up here times 5. 5 is equal to 10 kips. That's the total load. Now, let's look at the sum of the moments about A is equal to 0. And that's going to be equal to negative 2 kips times 5 feet. I don't have to worry about this 2 kips because it's 0 feet away from RA. But I've got this 2 kips 5 feet away. Then I've got plus minus 2 kips times 10 feet away. That's this one. And then I've got another one. So that's plus minus 2 kips times 15 feet away. And then also there, 15 feet away is RB. Let's say plus RB times 15 feet plus, I've got a 2 kips out on the end here, and that's going to be 20 feet away from RA. So plus negative 2 kips times 20 feet. And notice I put all of these as negative 2 kips because they're going counterclockwise. Yeah. Actually, I said negative 2 kips because they're clockwise. And I've put RB as positive because it's going counterclockwise. As long as they're, opposite sides, you're good. Okay, so I can start solving this. I can say that this whole thing is equal to 0 is equal to negative 10 kips feet minus 20 kip feet minus 30 kip feet plus or 2 times 15 feet minus 40 feet. You can say 0 is equal to, going to add all of these kip feet up and say negative 10 minus 20 minus 30 is negative 60, and negative 60 minus 40 is going to be negative 100 kip feet plus RB times 15 feet. And then I can move the 100 kips over and say 100 positive 100 kip feet equal to RB times 15 feet, divide by 15 feet, divide by 15 feet, RB is equal to 100 divided by 15, 6.66. So RB is going to go to 6.66 kips. Okay. And then to get RA, I'm going to do the sum of the moments about around RB. That's going to be equal to 0. That's going to be equal to, let's go right to left this time. So I've got this 2 kips on the end. And let's see, that's going around RB. That's going to be clockwise. So I'm going to say that's negative. I'm going to say negative 2 kips times 5 feet. Okay, that's going clockwise, so it's negative. So then we got this 2 kips, but it's 0 feet away from RB, so I don't have to worry about it. Next, we got 2 kips, and it's 5 feet away from RB, and it's going counterclockwise. So that's going to be a positive. So I can say plus 2 kips times 5 feet. It takes care of that one. Okay, then moving over, there's another 2 kips, and this time it's 10 feet away in the counterclockwise direction. So 2 kips times 10 feet. And then on the end here, got another one, so it's a plus 2 kips times 15 feet away. And then I can say this is RA, and RA would cause a moment going in the clockwise direction, so it's going to be negative. So that's going to be plus negative RA times, it's 15 feet away from RB, 15 feet. Okay, now I can start solving this out. So 0 is equal to negative 10 kip feet plus 10 kip feet plus 1 kip feet plus 30 kip feet minus RA times 15 feet. And I can add up these kip feet, say 0 is equal to, well, these two kind of counter out. I got 20 plus 30 is 50 kip feet minus RA times 15 feet. Now I can move RA over and say RA times 15 feet is equal to 50 feet. Divide by 15 feet, divide by 15 feet. And RA is equal to, it's going to be 3.33 kips. And now I want to double check to make sure that I've done this correctly. And I should be able to add RB and RA to add up to the total load. So 6.66 plus 3.33, does that equal 10 kips? It does, so we're good. We know we did it correctly.